We have the last keynote of the day now, following which we'll have the last panel discussion. So ladies and gentlemen, without further ado, Bill Liao, General Partner at SOSV, who is here with us today to share lessons learned from 10 years of investing in cellular agriculture for food. Let's welcome Bill with applause.
G'day. I'm not here selling anything, so I have no fancy presentation. What I am going to share with you is just some lessons I've learned as an investor in the cellular agriculture, or as some people call it, precision fermentation space. To give you a little background, SOSV, which is the fund I'm a general partner of, we owned and I co-founded IndieBio, which some of you may have heard of. We are the highest volume investors in life sciences and biotech on the planet. By highest volume, I mean we do the most deals. So we have hundreds of companies in our portfolio in this relevant space. We've participated in something like 7,000 funding rounds with our companies. And so we kind of get to know a little bit about the spaces that we're interested in. And we have been interested in cellular agriculture since about 2014 when we started IndieBio. In fact, in the very first batch of, back then it was called SynBio Accelerator, that I ran in Ireland, one of the companies that we had in there was a company called Perfect Day. Some of you may have heard of Perfect Day. They're one of the leaders in making milk without cows. And Perfect Day actually ferment milk proteins using brewer's yeast that they have hacked for that job. How many people, just quick show of hands, how many people here are startups? Few. How many are investors? Few more. Okay, so now try and keep it balanced. So some of the things that we've learned about cellular agriculture. Well, first, what is cellular agriculture? Put simply, it's putting microbes into an environment where they make something that you want. At its best, you are taking a very low value sugar molecule and turning it into a very high value protein. Most of the techniques for cellular agriculture were perfected in the pharmaceutical industry. And the reason that I got interested in cellular agriculture in the first place was that my daughter is a type 1 diabetic, and all of her insulin is made using cellular agriculture. It's made using Chinese hamster ovary cells. That's one of the things I learned in this many years of investing, is that a lot of pharmaceutical companies are making proteins using a cell called CHO, Chinese hamster ovary cells. Why they use Chinese hamster ovary cells to make insulin, I don't know, but I think it has something to do with their resilience. Apparently, you can find these CHO cells in the ventilation systems living quite happily of some of the facilities where they're actually producing supposedly just insulin. So that's one of the first lessons that I learned about cellular agriculture or precision fermentation. It is incredibly messy. It is not neat. It is not tidy. It's not like code that you can easily debug. It is very messy, very complicated, and it is hard to perfect. I'll give you an example. I have a company that is called Sundew, and they're making a really amazing small molecule that is going to replace formalin in the aquaculture industry. Now, formalin is this incredibly toxic chemical that they use to kill a disease called white spot. Sundew make this stuff called biocos, which is a byproduct of a bacterial fermentation that does the same job, kills the white spot, but it's completely non-toxic. Great, you think, great. Take a toxic chemical that's expensive out of the environment, put in a natural chemical that kills only the pest. Fantastic. Getting that to scale up into big enough bioreactors in order to make enough of it is an incredible challenge. And you could be shot in the foot in the most unusual ways. So for instance, they were trying to improve the yield. They were trying to get more of the biocos coming out of the bacteria. So they were doing a whole lot of trials. And through these trials, suddenly their yields started to go down and down and down and down and down. And they went back to the original formula, and still the yields were terrible. It turned out that in creating what they call the inoculant, which is a small batch of the bacteria to then put in the big bioreactor, they were relying on a little membrane made by a company, a normal, large pharma company. And this little membrane is supposed to be porous, so it lets oxygen in, but it doesn't allow it to be contaminated. So these semi-porous membranes that cost, 10 cents each, every single one in 5 batches was non-porous. There was a manufacturing defect. So roughly $300,000 worth of work was disrupted by a 10-cent part being unreliable. There is a lot of that going on. Because it's such a complex thing, it is difficult to figure out what the problems are in creating scale. So, lesson 1, it's messy. Lesson 2, it's actually very expensive to scale cellular agriculture. Perfect Day, the company that I mentioned, raised around about $350 million, and they have managed to get over their valley of death to the point where they have approved products. So if you think you're going to start in cellular agriculture and you're just going to drop a few $1,000s and then you're going to get to scale, you're kidding yourselves. Getting to major scale is extremely expensive, and it will be for quite some time. The next thing I learned is that bioreactor capacity in some places is extremely limited. Now, a bioreactor is just basically a big vat that you can control the conditions in to grow your little microbes. We do it all the time, and every time you've had wine, beer, or cheese, or yogurt, you've been eating the product of a basic bioreactor. The problem is, life is a little uncooperative, and so when you fill a bioreactor with stuff to then grow it, you have to have very precise conditions. And the kinds of bioreactors that you can do that in are a little bit hard to come by. In Silicon Valley, there is a bit of an oversupply because of so much money going into the field, but in the rest of the world, there's an undersupply. To the point that in Australia, for instance, they are converting wineries into bioreactor plants. Now, that is also an extremely bad idea. I know that if you want to have a reasonably controlled bioreaction, you need to put it in a building that is pretty well controlled. And by that I mean sterile. The average Australian winery does not rise to that standard. And retrofitting an old building to those standards, not likely to work. A tiny amount of contamination into a giant bioreactor can destroy the entire batch. And this is a lesson that the pharmaceutical industry has learned a long time ago. If you go to an insulin production plant like Novo Nordisk and you look at the conditions that they run those huge million-litre bioreactors under, they are cleaner than a silicon chip fabrication plant. They are class 1 clean rooms. And that is because they've learned that a tiny bit of contamination is a bad thing. And we've learned that too. So what we are seeing in the world is a big trend towards outsourcing the fermentation. And this leads us on to the next lesson that we've learned. It is so far untested as to how well the intellectual property is protected in a lot of these companies. So we see, for instance, sweet protein companies. There are literally now dozens of sweet protein companies. We've invested in a couple. Some of them have been funded, some of them are scaling. But despite the fact that they have multiple patents, there seem to be more and more coming onto the market. And so one of the things that I'm anticipating is some very large either consolidations or legal battles over who owns what. It's fine if you have know-how, but know-how tends to walk between the places. Because the other thing we've discovered, and here's one of the other lessons we've learned, fermentation capacity know-how is somewhat rare. Bioreactors are big, complex machines that interface with life, and life is really complicated. And life has a tendency to want to do its own thing. Even if you modify a cell to produce insulin, say, or to produce a sweet protein, that cell has an interest in doing its own thing. And it will tend to evolve quite quickly away from doing the thing you asked. And so there's a lot of moving parts, not just physically in the bioreactor, but also in the supply chain of it, also in the management of it. Temperature is a factor, oxygenation is a factor, waste product removal is a factor, inoculation is a factor, and all these factors multiply together. And people who have the specific expertise to figure out how to drive your bioreactors are not common. And they're kind of undervalued. So a lot of those people have been swept up, and you might be able to get yourself a 1 million litre tank, but you won't be able to find anyone to drive it. So there is a strategic advantage in the ones that have been early and have already got their hands on manufacturing capacity. They are having a much easier time scaling than the ones that are trying to outsource now. And another thing that we've learned is the hype cycle for biotech and for cellular agriculture is in its sort of first dip, which means it's probably going to come back fairly strong soon. But right now, it's not easy to get the companies funded as it was just, say, 5 or 6 years ago. So that first hype cycle is gone, and now people are waiting for delivery. Some companies are delivering, and they're moving up into supply chain. But a lot of companies that are starting out now are having a difficult time raising money because the promises that were made back in 2018 or 2016 are not being delivered on right now. Now, there will be. I can tell you from insider knowledge of a lot of companies that progress has been astronomical and that there will be deliverables. But for someone just starting out, there's a lot of previous sunk capital that is waiting for a return that is going to ignore you until some of that cash starts to come back. So until we see our first big exits and that cash being freed up, it's probably going to continue to be quite hard to raise in cellular agriculture for the moment or for the time being. The last thing that I've learned is probably one of the first things that I've learned too, is that because the science is so front and center, there is a journey for the scientist CEO to make to become investable that a lot of science-based CEOs have not undertaken the learning to move from one area, being science, into the other, being startup and business. And if you think about science, science is organized around the rigors of doubt. If you do not have doubt, you do not have the rigors of doubt, you don't have scientific method, you don't have science. And these companies don't work without science. It is not commoditized. You know, at this point, the silicon industry, most of the science is sitting in Taiwan at TSMC, right, at the fab. Here, all the science is still right in there with the bioreactors and the labs and the manufacturing. So this is a very science-heavy area. If you don't have scientists, it's not going to work. The entire startup and entrepreneurial covenant is based around conviction. If you don't have conviction in what you're doing, you won't raise money, you won't hire people, you won't be able to get consumers. Conviction is everything in entrepreneurship and investment. So there's a transition to make from somebody who's grown up understanding that the top organizing principle is the rigors of doubt to the top organizing principle being conviction. And you can't replace one with the other. If you replace science with conviction, you get Theranos, right? You get Elizabeth Holmes, pseudoscience. On the same hand, though, you can't leave conviction out of the equation because without conviction, you're just not going to get the money. And so the last thing that we learned over time is that there is an enormous amount of effort has to go into getting the team to understand both sides of this equation, that the science is enormously important and the conviction is enormously important. And getting scientists to learn what to have conviction about and not to have doubt about is a crucial factor in making these extremely big bets, because they are very big bets, they're hundreds of millions of dollars of investment. To get them to work, you need that critical ability, not to balance the two, but to be able to use both, and use both at the same time. So in summary, I would say that there is actually an enormously bright future for precision fermentation and cellular agriculture. The efficiencies alone that you can achieve make that true. But the road is much tougher than it was because funding is harder, and don't expect it to be an easy investment if you're an investor, and don't expect it to be an easy sell if you're an entrepreneur. Thanks very much.
Thank you very much, Bill. Quite an inspiring closing keynote, I have to give it to you. And I would say that pseudoscience is one thing, now that you've mentioned Elizabeth Holmes, and gullibility or wishful thinking is quite another in the industry or in the industries across, right?
Yes, that's true. If you are entirely about conviction, it's easy to get conviction about the wrong things, which is why the rigors of science are so important, but the rigors of science don't actually raise you any money.